We would like to continue to the next part of the afternoon talks. Please take your seats. The topic of the talks is Paradigm Change 3, Reconsidering Embryo Selection. Our first speaker is once again Dr. Norbert Gleicher. He's the medical director and chief scientist at the Center for Human Reproduction, New York. He is the president of the Foundation for Reproductive Medicine, professor adjunct in the Stem Cell and Molecular Embryology Laboratory at the Rockefeller University. He's editor-in-chief emeritus of the Journal of Assisted Reproduction and Genetics and the American Journal for Reproductive Immunology. The title of this talk will be, As Practiced Today, Embryo Selection Marginally Benefits Few, while potentially harming many.
Thank you, Aya. I now know all the titles. So 2 in a row, and I'm covering another topic where we are trying to raise some questions, and some of the speakers, particularly Dr. Albertini yesterday in his plenary lecture, at least partially raised this topic. Embryo selection is one of those wonderful sounding concepts. Who does not want to select the best embryo? And therefore, it is not surprising that embryo selection has been around since the very, very early days of in vitro fertilization. In various incarnations, and is being practiced till today. And I want to address this today, both clinically and on a basic physiological level. Basically coming to the conclusion that maybe here is yet one other area where it may be time to have second thoughts about long-standing practices. So once again, I do not think that I have any conflicts here that relate to this particular topic. I will be addressing very quickly the history of embryo selection. I will be discussing why the biology of reproduction in many ways speaks against the concept. I will spend a little more time on Blastocyst stage culture, another topic that was discussed in this conference already, because it is the most widely practiced method of embryo selection today. And I will briefly discuss other embryo selection procedures. Basically, those of you who want to hear even more detail or read more detail, the basic idea of this presentation was recently published in this paper. So I mentioned already that embryo selection has been around since the early days of IVF. But, does it make biological sense? And what do I mean by that? As I showed you, I think I showed you this slide yesterday already, making the point that after a follicle is recruited and starts its maturation journey of anywhere between 2 and 4 months, some people say even longer, this involves quite a number of what we currently consider menstrual cycles. But for that follicle that starts this journey, the cycle is not 128 or 30-day cycle, but it is this whole period of 2, 3, 4 months. And during all of these stages of follicle maturation, the ovarian microenvironment very significantly affects oocyte maturation and in many different aspects. Until this follicle reaches ovulation and a mature oocyte is extruded, which gets fertilized, the resulting embryo is 95% oocyte dependent. As you heard yesterday also in detail, while there are very important contribution from the sperm, the majority obviously comes from the oocyte. And on a biological basis, one has to wonder about the concept that we have an egg mature for so long, be for so long under the influence of its microenvironment, then get fertilized. All of these developments have to play an overwhelming factor, offer overwhelming contributions to the final product represented by the embryo. And it seems on a biological basis kind of a little bit naive to believe that at the end of this long journey, that what's left for us to do to affect quality is still in any way really significant. Very hard to believe. And therefore, when you, I think, start thinking about it in that way, you start maybe better understanding why whatever embryo selection method you look at, none has really demonstrated any real significant outcome benefits for our daily clinical IVF practice. And as I will show you, I think pretty convincingly, even in regards to blastocyst stage culture, there are significant questions to be answered. So let's talk about blastocyst stage culture. I think this was also yesterday already mentioned. There have been a limited number of meta-analysis on the advantages and disadvantages of a blastocyst stage culture. The first one was by Blake et al., and these are all Conrad studies. And the second one by Glujovsky from Buenos Aires. And the materials, the number of studies that are of at least minimal quality to be evaluated in a meta-analysis is very, very small. So I cannot stand here before you and tell you that the conclusions of these meta-analysis are very strong. But they are interesting because they make sense. At least they make sense to me. And what these both meta-analyses demonstrated is mostly not surprising. The first finding, I think all of you are aware of and will agree with. And that finding is that if we culture an embryo to blastocyst stage, day 5 and or 6, an embryo selection process takes place. That means on the way between cleavage stage day 3 and blastocyst stage day 5, 6, some embryos will arrest. Those embryos that will make it to blastocyst stage have a higher implantation rate than embryos transferred on day 3. So we have selected out what I like to call not best,
but maybe strongest embryos. But what the meta-analysis by Gleicher for the first time pretty convincingly demonstrated is that there is a second consideration to be made. And that second consideration applies to a large majority of patients. Because I would argue that what we just discussed, that through embryo selection, we are selecting the strongest embryos with the best implantation chances, that applies only to a minority of patients. Because in order to select out best embryos, you have to have enough embryos to select from. If you don't have enough embryos, and if there's nothing to select from, in other words, to go to the extreme, if the process starts with less embryos than you're willing to transfer into an uterus, what's the advantage of further selection? You can only lose. And that's where the study of Gleicher comes into play, because what he demonstrated in the second meta-analysis is that things look quite differently if instead of looking at implantation rates at time of transfer, you look at cumulative pregnancy rates per embryo cohort obtained in a single IVF cycle. And what he demonstrated is that if you look at IVF cycle outcome in that way, in other words, what is the cumulative pregnancy rates from all embryos transferred, first fresh and then progressively from frozen? In every patient, from poorest prognosis patient to best prognosis patient, the cumulative pregnancy rate will be significantly higher with day 3 transfers. Now, there's only one explanation for this discrepancy, that on the one hand you get highest pregnancy rates with day 5, 6 transfers, but you get universally lower cumulative pregnancy rates, and that one explanation is that between days 3, cleavage stage, and days 5, 6, blastocyst stage, some embryos arrest, which, if transferred on day 3, still would give you a perfectly healthy offspring. And the way how I explain this to our patients is that even though we have great embryology and wonderful incubators, I tell my patients that their uterus is a much better incubator than we have. And I think that is indeed the case. Now, it is also important for you to remember that when the Colorado group for the first time correctly reported that blastocyst stage transfers have higher implantation rates, that was on a highly selected patient population. Highly selected in 2 ways. First of all, highly selected in that they didn't take patients with elevated FSH or lower AMH into consideration in the first place. But secondly, obviously, highly selected because, as we just discussed, some embryos will die off on the way between day 3 and day 5. And therefore, some patients will not have any transferable embryos by day 5. And they don't show up in transfer statistics of only day 5 transfers. And therefore, it is not surprising that once other centers started repeating the studies of the Colorado Center, they could not get the same results. And they didn't get the same results because they didn't get the point that the Colorado Center had highly selected the patients that they reported. And so they applied blastocyst stage cultures to everybody. And this is what is going increasingly on in IVF practice worldwide. And this is what I would like to warn you from, because if you use a blastocyst stage culture indiscriminatively on everybody, you will harm some patients. Indeed, you will harm quite a number of patients. And here, I'll show you this concept graphically. So here we have the various days of culture. And here, you see graphically what I told you about before in white bars, that the longer your culture, the higher the implantation rate will be. But when you look at cumulative pregnancy chances, which are in the black bars, the longer your culture, the lower the cumulative pregnancy chances. And if you put all of this together, and there are another 2 meta-analyses in the literature that show that, what you will find is that you get this effect of the improved implantation rate only in good prognosis patients. If you have average prognosis patients, you will see no outcome difference. If you have poor prognosis patients, which are usually patients who have relatively small egg and embryo numbers, you will have negative outcomes because you will lose embryos. So why do we get the benefit in good prognosis patients? Because in those patients, even if you lose a few good embryos, it doesn't matter. They will still have their best embryos available for transfer. But if you have a poor prognosis patient who has very few embryos, and those embryos even may be a little marginal, if you take that patient to blastocyst stage, there's a high probability that they will arrest on the way, and you will have taken away from your poor prognosis patient that little pregnancy chance that she might still have had with a day 3 transfer. Now, there are other arguments against blastocyst stage transfer, and you have heard some of those here yesterday. There are increasing concerns about the epigenetics of extended embryo culture. You heard quite a number of voices yesterday about how little we know about the media we are all using, yet there is increasing evidence that media make huge differences in epigenetic imprinting. This was, all of these concerns were probably best summarized in this recent paper by the Scottish group, and by this diagram that I think one of the speakers yesterday, I think Vitaly, showed you as well. So a word of caution, therefore, about the quickly spreading concept of blastocyst stage culture. And even though this is not the topic of my talk today, but blastocyst stage culture is obviously also a prerequisite for 2 other embryo selection procedures. The embryoscope, which was one of the recent fashions of the moment, but we are hearing less and less about it. And then obviously PGS, which has been a main subject here at the conference, particularly in one of the workshops before this conference even started. So to summarize the blastocyst culture story, if you have a patient who is young and has normal functional ovarian reserve, there may indeed be a benefit to blastocyst stage culture. Those are your good prognosis patients. If you have your average prognosis patient, you will see no effects, and one has to really wonder why then do it, particularly in view of concerns that have arisen about blastocyst stage culture, and as you also heard one of the speakers yesterday correctly stating, increased costs. And if there is one message that I'm trying to get across to you today is if you have a poor prognosis patient with low ovarian reserve, with small egg and embryo numbers, please don't ever culture them to blastocyst stage. You will reduce their pregnancy chances. Now, I made that point already. Two other increasingly popular embryo selection procedures are, of course, PGS and use of the embryoscope. When we indeed look at the concept of embryo selection, it's an inverted pyramid. All of these are selection processes. We select by age, we select by functional ovarian reserve based on FSH, AMH, antral follicle count. Then we select by blastocyst culture. Then patients are now being sent increasingly into PGS. And we end up with obviously a tiny, tiny fraction of the initial patient pool after all of these procedures who reach embryo transfer. And I cannot overemphasize the importance of this point. When you are analyzing any of these steps, and when you're being told that PGS, for example, improves outcome, and if that outcome improvement only relates to the patients who had an embryo transfer, then you are receiving the wrong message. Okay? Because you always, in your outcomes, have to look at intent to treat at the patient who starts the cycle. If you exclude all the bad prognosis patients and end up after this whole series of selection processes with only really the best prognosis patients, you're really fooling yourself into believing what your real outcomes are. We have come to the conclusion that PGS, not PGD for single gene diseases, of course, but PGS for the determination of chromosomal abnormalities is really a worthless procedure. We very strongly feel that a single trophectoderm biopsy at blastocyst stage cannot reliably discriminate between embryos that can be transferred and those that should be discarded. And so we very strongly urge you, if you have started using PGS, to stop doing that. A word about cost effectiveness. I've already mentioned that any embryo selection really benefits only good prognosis patients. But I can tell you that even in good prognosis patients, for example, blastocyst stage culture, while it improves your clinical pregnancy rates to a significant degree, the improvement is really marginal. Because if you have a real good prognosis patient, whatever you do with that patient, she will give you a great pregnancy rate and a great live birth rate. And so even though an embryo selection method like blastocyst stage culture may give you a statistically significant increase, one has to really ask whether it is a cost-effective procedure. That study hasn't been done, but it's certainly worthwhile doing. 1 second on the embryoscope. We are going to get the lecture on this subject, so you will hear more. But that's the current price for an embryoscope, which, except for one study so far in the literature, has not proved, I'm sorry, as of last week, 2 studies in the literature, because Zev's group just published, I must say, an interesting study where they noted that the inner cell mass parameter, an increasing inner cell mass parameter was a good prognostic sign in terms of pregnancy to a statistically significant degree. If that can be repeated, that would really be the first finding where the embryoscope has any prognostic relevance. Every other study, pretty much otherwise, was either underpowered, wrongly calculated, or simply didn't show anything. So, again, a word of caution about embryo selection via the embryoscope, especially if an instrument has to cost so much money. We did, indeed, a little study on an embryoscope. We did not buy it. We got a loaner, and this was just by principle, because we do not at our center make any significant changes in laboratory policies unless we are absolutely certain that they don't harm and actually hopefully improve outcomes. So we test out everything very carefully before we make a change. And we tried to get loaner instruments to see how how these instruments would work in our patient population. We contacted 3 companies. 2, when they heard we want to do a study, said no, not interested. The 3rd one was generous enough to give us a loaner for a few months. They were small studies, and we in principle did 2 studies. They were both randomized. Well, first of all, in our standard patient population, which is a very poor prognosis patient population, and this is one reason why we cannot believe necessarily data that we see in the literature, because our patient population is so different. So the first was a randomization of patients to the embryoscope and to standard embryology, and we found absolutely no difference in outcome. Now, we did also we did also a time study, because one of the claims of the of the industry that we heard on multiple occasions was that these instruments save you embryology time, and we actually found exactly the opposite. We found that our embryologists spent more time with the embryoscope than in standard embryology. And then we decided, since there was one study in the literature from the Ivy group in Spain, which had shown a mild outcome advantage for the embryoscope, but which had 60% egg donor population, we said maybe their results are due to their patient population versus our patient population. So we decided to go to the other extreme. And we looked at the performance of the embryoscope in donor cycles, exclusively donor cycles. But there we didn't randomize patients, we randomized eggs, embryos. And what we, I'm so sorry. Okay. What we find there, so this was the patients, these were the donors, and what we found there is that actually our embryoscope significantly reduced the embryo quality that we ended up getting in those best prognosis patients. So that was very worrisome. We had the instrument only for 3 months, Therefore, we did not have the ability to accumulate enough data to do statistically significant pregnancy rates and certainly live birth rates. But the poorer embryo quality was surprisingly obvious to us all. And just as a little anecdote, since I saw her here in the room before I started this lecture, one of our senior embryologists who had been going at that time through IVF herself, when we got the instrument, she begged me to allow her to go outside of the rotation into the embryoscope with her embryos. And I wouldn't agree to that. By the time we repeated her cycle, she begged me not to go into the embryoscope with her embryos. So that's so much on our small experience with the embryoscope. And I think that's it. And I thank you very much for listening.